the keynote speech of Professor Werner Sobek is taking part, but before Professor Sobek's speech, now it's a great pleasure for me to welcome our Dean, Professor Meltem Gürel, to make the opening speech. Professor Gürel.
Thank you, Yana. Thank you very much. I assume everybody can hear me. So dear distinguished speakers, colleagues, and students, it is indeed my pleasure to welcome all of you to the second Architecture, Technology, and Innovation International Symposium. This symposium is organized by Yaşar University's Department of Architecture in order to offer insights into the role of technology and innovation in the practice and critical theory of contemporary architecture. We hope that this annual symposium will be a cultivating scientific platform for scholars in the field to meet and discuss the developments on architecture, technology, innovation, and their effects on the practice and theory. As you know, this year's theme is Designing for Uncharted Territories. The condition of constant change is a significant aspect of today's world. The rapid and groundbreaking transformations in the mutual relationship between social systems and technology have introduced uncertainty in each aspect of everyday life. This uncertainty raises the question of what to expect from the future. The symposium tries to address this question. In the next 2 days, I'm looking forward to listening to intriguing papers covering different aspects of the theme. We will have the opportunity of listening to 16 papers in 5 different sessions, covering first, structures and materials, second, spatial practices and utopias, third, future-proof and extreme scenarios, fourth, energy efficiency, and finally, smart cities and urban ecologies. We will also have the opportunity to listen to very interesting keynote speeches, first by Professor Werner Sobek this evening, shortly. And on September 24th, we will have our closing keynote speech by Onur Yücegün. I invite all colleagues and students to join these speeches and contribute to the discussions. Before we start, though, I would like to thank first to Yenal Akgün, the head of the organizing committee and vice dean, also to Ahenk Yılmaz, the chair of the Department of Architecture, and to all of my colleagues in the organizing committee, namely Arzu Cülasım Kunduracı, İpek Ek, Mauricio Gabriel Morales Beltran, Matthew Joseph Pedargana, and our dear research assistants, Ömer, Ecenur, Deniz, Duhan, Aysu, and Nur, for their dedication in organizing this event in these very, very difficult times. Finally, I would like to extend my special thanks to all of our participants. We look forward to your contributions and the discussions. I wish you all a very enjoyable and productive symposium. Thank you.
Okay, thank you so much to Professor Gürel for her opening speech. Before the speech of Professor Sobek, I would like to make an important announcement. This is really important. Professor Sobek really wanted to attend this session live, but he had to make an unexpected trip to Italy. Because of this situation, he had recorded his speech, and now we are going to watch this pre-recorded speech by him. Before listening to his speech, I would like to introduce Professor Sobek briefly. Werner Sobek is the director of Institute for Lightweight Structures and Conceptual Design. This is called ILEC in University of Stuttgart in Germany, and he is the founder of Werner Sobek Group. He studied architecture and structural engineering at the University of Stuttgart as successor to famous architect and engineer Frei Otto and engineer Jörg Schleich. Werner Sobek advocates a unique approach of bringing architects and engineers together, both during their training and in their professional activities. The ILEC specializes on research into new materials and new concepts for lightweight and adaptive structures. And the Werner Sobek group engages in innovative engineering combined with design of constructional elements and sophisticated concepts for sustainable buildings. Professor Sobek holds the Mies van der Rohe Chair at Illinois Institute of Technology in Chicago. He has also taught at Harvard University, University of Graz, MIT, Columbia University, the University of Hamburg, the University of Hanover, and the National University of Singapore. Werner Sobek has received the DuPont Benedictus Award, European Blue Lamp Award, Fritz Schumacher Award, IF Design Award, Seoul Structural Engineering Award, and AIA Awards of the American Institute of Architecture. Plus, I forgot, Hugo Hering Award and Fazlur Rahman Han Medal and the UIA's Augusto Pere Prize. He's also the former president of the board of German Sustainable Building Council, which is also very important to me. I wish an enjoyable speech for all participants. Now, Ömercan, could you please start the pre-recorded speech? Thank you very much for attending to this session, to all participants.
Good evening, ladies and gentlemen, dear Rector Cemali Dincer and dear Yenal Akkün. Thank you so much for inviting me to give a keynote lecture at your ATI Symposium at Yazar University. Unfortunately, due to the corona situation, I cannot attend in person, so I give this lecture virtually or digitally, however we might see it. My lecture is entitled 2.6, which is probably the most important number of our times. However, I'm quite sure that most of you never heard about this number, so I will keep the mysterium for a couple of minutes before I'm going to explain what I mean with it. Let me start with this. This is a photography taken by a NASA satellite, and it shows this tiny dot here, which is the house we are all living in. And I might add, the house where we cannot move out. This has to be compared to Saturn, Venus, and other comparatively huge planets. And we can see our planet as a spaceship, where we are all sitting on top of it and where we are cruising with 100,000 kilometers per hour through the space. The only problem we are facing is that we have no operation manual for our spaceship. The question might be, what is the objectives? Architecture and engineering, all the people building the so-called built environment, what we should fulfill. And what are people wishing? What do they expect from us? It is quite simple. It is a healthy and fulfilled life in line with the others and, very important, in line with nature. Architecture, so to say, is nothing else than the attempt to build something where there is no word in English for. In Germany, we call it Heimat. So this is the place where your body as well as your soul finds home, Heimat. This is what we have to achieve. And facing nowadays problems and facing the fact that we have to change the way we are designing our cities and metropolitan areas, the way we are designing our infrastructure building as well as housing. We established a couple of standards, especially such which try to guarantee a certain level of sustainability. And the European Union already a couple of years ago formulated those 3 pillars which we always should consider when designing cities, buildings, and other things, that we should look at the ecological sustainability, that we also should consider the economical sustainability, and of course the socio-cultural sustainability. And the amount in the intersection here, this area which meets all the 3 requirements, this is ideally the place where we should place our designs. Architecture and building in general is an anticipation of the future, which is quite difficult because everyone will say, what is the future and how should we know about future? But if you make it clear that you, being architects and engineers, today think about what is going to be erected in 2, 3, 4, 5 years, and what is then inhabited, it is in fact talking about future. So we all have to implement future economical, ecological, as well as social aspects. And in my opinion, this means that we should talk much more about future than we do nowadays. Architecture and the built environment in total is the entity. So many people say we face an energy problem, we have to be energy efficient, and so on and so on and so on. And some people say we have an emission problem. Typically, a few only talk about resource problem. Let's enlighten these 3 aspects, which are a component of the 3 pillars of sustainability, especially the ecological as well as the economical one. And let's ask critically, do we have an energy problem? And I say, no, we don't. We have to consider and we have to look at the relation between the solar energy, which is hitting our planet, and the human beings' need. And the relation is 10,000 to 1, means we are overloaded with energy just by sun radiation. The sun delivers 10,000 times more energy than the human being needs for all their activity. So how should we talk about an energy problem? We do scientifically not face an energy problem. And there is much more energy available. We talk about wind, we talk about waves, we talk about geothermal energy. So it is quite obvious that we do not have an energy problem in total. We have an energy problem. We might have one if we look at the sources we are using. We are delivering energy on the basis of combusting fossils. In doing so, we cause emissions. And those emissions, dominantly CO2, are responsible for the global warming. This is the problem we are facing. So it is an emission problem. And this is also while the Paris Treaty, which has been signed in 2015, asks for an end of the supply of energy based on the combustion of fossil materials in 2050. This does not mean that we can continue as we did in the last 150 years with a way to supply energy and then in 2049 take a sharp right turn and completely change our energy basis. It means that we have to provide a decline, and I'm going to talk about this decline. Is it a linear decline from now on until 2050, or is it a non-linear decline? We are going to understand this in a few minutes. There have been attempts to overcome these emission problems. I designed a house which became somehow famous. It's called R128 already in the year 2000. And if you look at it It is characterized by the fact not only that it is all glass, etc., etc. What is important in the context of my talk is that it is minimized when we talk about materiality. It consumes only 15 to 16% of the material used in standard housing. It is, in the years balance, energetically neutral, and most important, it has no chimney. It has no chimney means it shows no emissions during lifetime. And besides, it's about 95% recyclable. So R128 is, I call that in contrast to the passive house technology with tiny windows and airtight buildings, exactly the opposite. It is the first active house ever where you have higher level of transparency, where you can breathe deeply the fresh air which flows through the house, because the problems we are facing is not whether the houses are airtight or not. The problem is global warming. And the question is, how do we overcome that problem? And there are more technology than just the passive housing technology, as you might see here. And then we did another somehow very well-known example for the German government. It is a building where the German government wants to show to political visitors the level of standard in building in Germany. This is a house which, again, is energetically independent, which has no chimney, means no emissions, and which, on the other side, is the first house ever which talks to his car in order to balance the electrical production of the house and the needs of the car. And then this is another and the last example we did when we talk about zero emissions. Again, this house does not show any chimney. There is no combustion. The house produces 200% of the energy it needs. So there's a huge energy overflow. And again, this house talks continuously to the electric bikes as well to the electric car of the owners. And for the first time ever in history, this house is digitally connected with a 90-year-older house in the neighborhood designed by Le Corbusier, which you might imagine is an energy sink. So the Corbusier building needs energy in a huge amount, and our new building has an overflow. And as long as they talk to each other, they might balance the need and the provisioned amount of energy. Interestingly enough, if you look at the house of Le Corbusier and the Mercedes-Benz car below, as well as the lady, you see the differences of avant-garde design in architecture at those years compared to the automotive and fashion design. We took the experiences we gained with these buildings, which are easy to be assembled, easy to be disassembled and recycled, which are materially minimized. And we designed a building which we call Active House, Series 700, where we produce the modular buildings in an industrialized way in order to lower the price, make it available for everyone, have a guaranteed price, and have a guaranteed delivery time of 12 weeks and after ordering. You see that we have clean construction sites. The erection is quite easy, simple and fast. The building which arrives on a truck is fully equipped with kitchen, bathroom, windows, etc. And for the first time ever, it is fully pre-tested in the factory. So we guarantee that after 1 hour, after arriving on the site, you might move in and take a shower. And of course, if we would take these rules, these objectives, if we take the know-how we gained in doing these buildings, it would be easy to create cities of tomorrow which show no emissions, which are characterized by the use of only a minimum of material, which are fully recyclable, and where, since they have no chimneys, no emissions, just run by electricity, we achieve the objective of the so-called electric city, a city which is relatively quiet and characterized by plenty of fresh air instead of the gases and dusts caused by cars and others. So this was a short excursion on how could we build units and cities which are based on our realization that we have no energy problem and that we have an emission problem, and that this is what we have to overcome, and that we have a resource problem because the availability of building materials is not longer given, at least not in any area of the world. Interestingly enough, as a sidekick, up to now we still require from architects and engineers that they demonstrate on the basis of their planning that the buildings they are designing do not use more than XYZ energy. This is not the case in the car industry. The governments require the car industry to demonstrate that it does not cause emissions of more than XYZ. No legal prescription is out there which talks about fuel consumption. And it is just the opposite what we are doing in the building industry, that we talk about fuel consumption, means a limitation of the energy consumption, but not on a limitation of the emissions, means we do not hit the point. And there is no fully linear and direct correlation between the energy consumption of a building and the emissions caused. So we are just running after the wrong target. And as an add-on, up to now, we typically consider energy consumption, better emissions, in the use phase. If we focus on the emissions, it is obvious that the use phase stands for 35 to 45% of, if we consider a 50-year duration period, of the total emissions caused by this building over its total life cycle. And in the production phase, the building emits 40 to 50%. But nobody considers this worldwide in the building industry. It means we are looking on the wrong problem. We do everything to minimize emissions, energy consumption in the use phase, which is a subdominant factor. And we do not focus on the production phase, which is the dominant one, and where all the emissions are blown up in the atmosphere now at the very beginning, before anyone enters the building for the first time. And then finally, not to forget, the so-called end-of-life phase, something no architect wants to think about. What is the end of the life of the building he stands for? Same is true for the engineers. But we have to accept that demolition causes a huge energy consumption and plenty of emissions, and that the transport of the building waste to some dumps, wherever they might be, is causing transport emissions in a relatively high level. So end-of-life phase stands for 10 to 15% of the total emissions caused by a building. These numbers are very, very important because they make it totally clear that we did not scientifically dig deep enough. We just focused on the use phase and did everything to minimize the energy consumption in the use phase. Now, if we focus a little bit this emission problem, you might ask, okay, what does it mean and why do we talk about 1.5 degree, which we have to keep, and if we do not, then at least dominantly below 2 And nobody really understands why is this 1.5? What is the problem between 1.5 and 1.8? And what does it mean if we emit so much emissions that we cause a warming of 2 or 2.5 or 3 degrees? I will focus a little bit onto that, giving you the clear information that the building industry in total, buildings as well as infrastructure, erection, use and demolition phase, stands for roughly 55% of all the emissions caused on our planet. So building industry is by far the most responsible industry when we talk about global warming. It is not the mobility sector, it is not the energy sector, it is the building industry sector. Means it is us, and it is our responsibility, and we have the lever arms to overcome that problem. Now, in context with the Paris Treaty, we talked about the global CO2 emissions and that we have to decline until 2050 to 0. This is the red line. And you see that we do not hit 0, we hit 5, because it is industrially considered to be impossible to really reach 0 by a reduction of the global emissions. So parallel to the reduction, we need removal technologies to take out the other leaving or leftover 5 gigatons, which is millionen, or in the Anglo-Saxon, billion tons CO2 per year. However, up to now, there is no technology available in the world which is capable to remove that much CO2 until 2050. There are first somehow experimental units going into use phase in Iceland, but to give you an idea, the capacity of the Iceland factory, removal factory, is such that we would have to install 1,000 of them per week until 2050 in order to take out the CO2 needed to be taken out of the atmosphere. So it seems technologically as well as financially relatively critical to really establish the yellow path. Means the red one, the emission path, has to be dramatically increased down close to 0 emissions. Now, what would it mean? 1.5, 1.6, 1.8? Look at this. The Paris emission path has a certain background. Why is it 0 emissions until 2050 and not until 2100 or 2040 or whatever? This is the combination between technological ability, capability, financial ability, and what the objective is to be reached. We are close to 1.2, 1.3 average value all over the world in our climate system. And this diagram indicates that if we would reach something close to 2%, that we would hit a very dangerous boundary. Beyond 3 degrees means outright chaos, and 4 degrees is incompatible with an organized global community. Why? Of course, there are dramatic changes. There is melting glaciers and melting ice caps, and the sea level is going to rise, and average temperature is rising, and you probably don't need to do more heating that much as we did in the past. Building industry runs in a cooling problem less than in a heating problem. But what is about this 1.7, 1.8? Why do we need to keep that? Let's shift that on the side and let's look on agricultural investigation and research, which clearly indicates here in the example of corn. in a publication of the United States Academy of Sciences, so top papers, which are supported by other researchers too, and which clearly indicates that if you have an over temperature for corn for a few days only, you have to face a dramatic reduction in crop yield. Means if you have a few days only in temperatures level 33, 35, 36 degrees, the crop yield decreases by 20 to 40%. This means nothing else that food production in the world is reduced by 20 to 40%, which is directly correlated to hunger or people dying because they have nothing to eat anymore. This is the background. So the limitation of global warming to 1.7, 1.8 as the absolute boundary to be kept has nothing to do with outside temperature and building heating and cooling and whatever. It is just hunger worldwide, which will cause the deaths of hundreds of millions of people, which we have to be avoided. This is the background. And since the building industry stands for 55% of the emissions worldwide, it is the responsibility of the building industry to dramatically contribute that we do not reach those levels. Now, the thing is that the CO2 and the other greenhouse gases stay relatively long in the atmosphere, so that they are out there. They don't go away. And as we already learned, it is very, very difficult to remove them, might be impossible to remove them with technical measures. Means what is out there causes global warming, and the more out there, the higher the global warming. But what is the contingent we can emit in order to keep 1.5 degree? It is seen from 2021, means from now, from today, it is 290 gigatons CO2 equivalent, which human beings are allowed to further emit into the atmosphere. This is a huge number, 290 gigatons. Everyone would say, okay, we will never reach that. The number is too big. I can't even imagine what a gigaton means. And the 2.0 degree, where we already fall in this catastrophic situation of hunger and social instability, is correlated to 1,000 gigatons. The question is it really that much, 290 gigatons? The question we should ask for is, how much do human beings emit per second? It is 1,300 tons per second, which means that we eat up the 290 gigatons, which are given there to keep the 1.5 degree limit in 6 years and a few months. 6 years and a few months which are left. And then we have eaten up the 290 gigatons. However, if we would start now with a dramatical saving, introducing all the technologies we have, reducing the emissions in the way we build our houses, we run our houses, reducing our personal mobility emissions, etc., etc., etc., we might come up with a linear decrease. So what would that mean? Look at the blue line. If we from now on linearly decrease the emissions, the 6 months, the 6 years and a couple of months would be projected to about 15 years, let's say roughly. So it is 2035, where the blue line hits the zero CO2 emissions per year. The area below the blue line, this is what is left over to be emitted. Everything more means we hit the 1.5 degree and we run into the problems I was describing before. Now, the building industry has about 50 to 55% of that. So this is what we have to fulfill. From now on, continuously, within 15 years down to zero, reduce the emissions during production of the material, construction of the buildings, use time of the buildings, and demolition. This is an incredible work to be done scientifically, practically, etc. Everyone has to pull in the same direction, otherwise we will not reach that target. Now, there is statements going out there around climate neutral, etc., etc. People told me a couple of weeks ago in a competition when I was sitting in a jury that they have a zero carbon building, and I looked at the building and I said, but there is plenty of tons of concrete containing cement in the foundation. How can you tell us that this is a climate neutral building? And then they said, yeah, we are using a lot of wood, and if we use wood, then we have a negative prefix or balance, and the negative of the wood and the positive of the concrete gives in total zero. So this is not serious. I said this is not serious, even if most people and even plenty of scientists are making those statements, because they all forget one thing. A tree has been collecting CO2 over the last 60, 80, 100 years. It is a very fruitful and important CO2 collector. If you now take the tree out of the forest and build a house of it, there is no longer any CO2 binding by this tree. So what the tree did in the past cannot be considered as a negative contribution to the contingent, the triangle here, of today and tomorrow. Why should it? People forget the fact that there is a start of accounting, and this is 2020. Everything before 2020 is not considered in the triangle. Everything after 2020 has to be considered. So there is no acceptance and ability to have negative emissions out of the past. Make it obvious. If this would be true, then you could drive your sports cars, because you could state they are using energy which has been collected and assembled in the form of whatever, petroleum, millions of years ago, and I give them a negative prefix, and today I emit them with a positive prefix, and the sum of it is zero. So this is not acceptable. It is a balance sheet trick, nothing more. Now everyone is still asking and waiting for the 2.6. This has something to do with the population growth on the planet. We have more or less stable over the last years 4.4 births per second. Unfortunately, 1.8 people average are dying per second, and the difference is the famous number of 2.6. This is the net increase of the world's population per second. What does this mean? 2.6, born somewhere on the planet. Now we have to give them a home. We have to provide them with a sleeping room, with a living room, with an area where they can work, with the infrastructural systems, at least schools, etc. So we have to build for them. We have to create what we call Heimat, gebaute Heimat, in the German language, for 2.6 persons per second. Now the question is, how much does a citizen of the world own in building materials? If we combine infrastructure as well as residential and non-residential buildings, this is a quite interesting question. Every architect and engineers should be capable to answer. It is, if you look at the so-called industrial areas or countries, roughly 460 tons per capita. Germany, Austria, Switzerland, even close to 490. So if you would provide 2.6 persons per second, an amount of material as those countries stand for, of 450, 490 tons, you would need to scratch up to 1,300 tons per second out of the surface of our planet, transform that material into building material, make pieces and parts out of it, transport them to the construction site, assemble them to build a house. Absolutely impossible. The material is not out there. And the emissions caused by the scratching out of the surface, by the transformation to building material, the emissions caused in these processes would yield to a global warming in the range of 4 to 6 degrees. So this would be the absolute end of the human society. Now there's a situation of the so-called third world. I never used that word, therefore I said it in abbreviations, because the ranking into a first and a second and a third world is quite dubious, in my opinion. Many people in the third world are much more wise than the ones in the first world. But we have to think about how many people live in the third world. What are they reaching out for? Is it also a living standard? It is education. It is access to health, etc., etc., etc. But this can be linearly transformed into amount of building material, because access to health means you need a doctor with a house, you need a clinic, you need a university hospital. This is built environment, and you need infrastructure to connect your position with the clinic, with the hospital. And the same is true for education. You have to have infrastructure to reach the school, and then you have to build the school, and you have to build a university. So this is material consumption. And if we now make it clear that out of 7.9 billion people actually living in the planet, 6.3 are so-called third world people, the question is, how much building material do they have? It's 76 tons. Might it be 70, might it be 80? This is not of interest, because no one can state that precisely, but scientifically the number is 76 plus minus 5. So this is the standard in the world, the standard. The industrial countries stand for this. And the catch-up of the third world in order to reach the standard of the industrial country is 2,200 gigatons. This amount of material is needed to raise the buildings and infrastructure standard of the third world to the one of the industrial world. Now, how much does the industrial world stand for? It's close to 1,200, means raising or lifting up the living standard, especially the educational and health standard of the third world, means that we would need an amount of building material which is more or less double the amount you find on our planet. This is absolutely impossible. We do not have the material, and you already know what the next statement is. The emissions caused by the production of that material would cause a global warming beyond any limits. So this is a political, it is a social question to be answered by everyone. It means that the catch-up of the third world, as we all permanently ask for, at least on our Sunday speeches, is not possible. We have to face the fact nobody talks about, even our branch architects and engineers is not talking about. What is the qualitative standard of the people living in this third world? 4.3 billions, which is more than half of the entire human population of the planet, have no access to an in-house toilet. Close to 1 billion have no access to any toilet. Close to 1 billion, this is 1/8, has no access to any toilet. Or up to 4 billion people, which is half the world's population, have heavy problems in water supply, have even zero water supply for average 1 month per year. 1 month out of 12, these people have no fresh water. And 3 billion, which is roughly 1/3 of the world's population, have insufficient water supply for more or less half the year. This is the situation we face. And this is the problem we have to solve. Resource problems. I already indicated that the amount of material needed to provide eine menschliche Heimat, this home for the 2.6 people increase per second, is not there, and the emission connected to it is impossible to be done. And the same is true for the raising of the so-called third world to the standard of the industrial countries. However, the term "it is impossible" does not allow us to stop thinking. We have to do everything. We have to invent. We have to be creative. We have to come up with new materials, technologies. We have to come up with new ways to build, new ways to live in the buildings, and new ways to use the building at the end and after the end of their lifetime. It is creativity which is needed by everyone, especially by the younger generation, because my generation stands for the fact that we do not do anything to solve the problems we know about since 50 years, except a few of people. So I said, let's put an objective there. Let's say, why do we not reduce the amount of material needed and the emissions caused when we work with concrete by 50%? This is a huge number, of course. But scientifically, it is a correct statement. Let's try to save 50%. And the solution is the optimization of the interior of building components. Means adding cavities everywhere where the structural loading, where the stresses in the concrete itself are close to zero or relatively low. So by eating up and taking out all the material not needed inside the building component, we in the meantime are capable, with the so-called graded concrete technologies, to save 50% of material and of emission. This is already something. There is a continuation of this graded concrete technology I do not want to talk about in detail now, which makes it much more simple to place the cavities on site, and where we come up with a new reinforcement technology which allows to save 50% of the steel compared to a standard slab. So 50% of concrete and 50% of steel saved by providing still the same structural capabilities, same loading, same deflection as a massive piece. The way, just as an example, we place those hollow bodies made out of 3 millimeter concrete on a formwork, in this case on a point loading on a single column situation, and where we have developed a new type of reinforcement, which is not longer the mats, which are relatively inefficient. So we work with sling reinforcement as you might see here in the blue slings, which then are anchored on the circular, hollow-bodied element, find a rigid body situation there where we unload all the forces or load their reinforcement, is a simple and a very fast technology on site. So this is one of the contributions we have been providing. We, as a relatively small institute, the Institute for Lightweight Structure and Conceptual Design, ILEC, at the University of Stuttgart, and the office founded by me in 1992, the Werner Sobek company of officers, to help to assist to overcome the problems I explained to you. Now there's a last point left. This is, do we always need primary materials freshly or taken fresh out of the surface of the planet? No, we do not. We could also work with secondary material, means with reused, recycled material and technologies. And this is a very famous example. The building in the middle, which is Enlightened, has been designed by me. And I have been supported in this case by Dirk Hebel and Felix Heisel. And we designed a building which is 96% recyclable, which consists out of 80% of recycled materials. It is a research project. So it is monitored by the University ETH of Zurich. The building stands a few kilometers out of Zurich in Dübendorf. And it is inhabited by 2 students, doctoral students. They are the test persons, and all their energy consumption and their social behavior and their feeling, etc., is continuously measured. So if you look at the facade, for example, these different colors, with a somehow African design, we could say this is copper sheets, which we collected from a couple of demolition sites. And then we took the copper and we somehow worked it up. And it was then me to combine the copper sheets in a way that their color, which is the original color, fits into a perfect picture, as you might see here. If we go inside, the ceiling is aluminum recycled. The walls are fully recyclable. Every wall is different in its composition. The door handles are reused. We rent these door handles from a Belgian company. They have been formerly door handles in a bank building in Brussels, which has been demolished. And they have been taken out before, and they are now in reuse in this building in Switzerland. This is recycled plastic waste. It is PET bottles, white, and other materials coming from other sources, together with blue PET. It's cut into pieces and then on low temperature somehow melted and baked together, and then it's cut to thin plates, and it acts as bathroom interior, kitchen interior, wall, etc., etc. So it's absolutely watertight. It is antiseptic, and it looks great. And it is recycled material. So recycling and building in a way that we use plenty of different materials to a high percentage in a new building, which are recycled, does not mean that everything has to look modest and somehow I excuse myself for being on the planet. No, people want to love the buildings they live in. So the materials we, as architects and engineers, are providing for those materials must be fulminant, must be wonderful, colorful, must look great. People must love to touch them, otherwise they don't fall in love with their building. Now, after this long journey discussing the energy problem, the emission problem, the availability of primary material, the way we can work with secondary material. And comparing this to the needs of human beings, to the 2.6 people per second increase, to the 6.3 billion people living in the so-called third world, and the effects coming out of these considerations, I would like to close with a few sentences only. So, it is clear that energy efficiency can't be the driver any longer. We have to introduce rules, technologies, or let's call it directives, for reducing the building emissions over their entire life cycle. And we have to introduce technologies, directives for circular building. This is the absolute must. So, the standard model of the three pillars of the sustainability has also to be changed. The new model is we have to keep nature alive. If nature does not function, there is no way for human beings to survive. Nature is the uppermost goal. So this is thesis number 17 of the 17th thesis I was proclaiming last year here in a Latin language statement, natura mensura est. Nature is the measure, not the capitalistic profit of everyone, not any records people are trying to achieve faster, longer, higher, whatever. No, it is keeping nature alive. Otherwise, there is no future for human beings. Thank you.
Okay. It was a great speech, remaining many questions in our minds, but unfortunately we are not going to have chance to ask questions to Professor Sobek about this wonderful speech. So let me close today's session. We would like to thank to our guests for participation. The ATI Symposium will continue tomorrow and on Friday, and the invited closing speech of Onur Yücegün will be held on 24th of September with the topic of From Algorithms to Meeting, Computation in Design. We hope that you will enjoy the whole program and look forward to your participation in the coming sessions of the events. And thank you for joining us, and good evening for now.